on this computer. There we go. Okay. You cannot minimize Zoom when you're recording this meeting. What? Sucks. Okay. I'm going to share screen. And we're going to share the whole screen. Look at that. Okay. Beautiful. So yeah, any concepts? Nope. Okay. Let's talk about what's in the course. Oh yeah. Has everyone here filled out my experience? Awesome. Good job. Tell us how much you hate us, how much you love us. Either way, it's fine. Okay. Pretty much everything is fair game. Like I'm not really going through this just to be like, oh, that's specifically going to be in the test. What I would really like, the thing about the exam is that, you know, OO classes, like all the basic stuff that we covered in the first couple of weeks, we expect you to be across that like 1,000% at this point. Mainly because that's what you've been doing all term, right? Like the building blocks, the foundations is, you know, you write a class has fields, has methods, like you've been doing that all term. So that's, you know, we expect that. The inheritance, the polymorphism stuff, understanding like polymorphism, not like how it's implemented, or the, you know, with pointers and v tables and all that kind of complicated stuff. But we do expect that you understand the concept around polymorphism. So when we say, you know, you've got an object of type B, which is also an A, then how does it behave when you run a method on it and all that sort of thing. Domain modeling is going to be a question, I think. Yeah, there should be a question where you get given a scenario and you have to essentially build a domain model. And it's going to be kind of like this one. Not this one, this one. So you have to come up with a bunch of classes, a bunch of methods, and a bunch of fields. But you're not actually implementing anything. So you don't have to write any code. You're just coming up with stubs. Does everyone know what a stub is? No? What's a stub? Empty implementation, right? You're just like, here's the method prototype, and then return null or return nothing if it's a void. So you don't actually have to write any code. You do need to say, these are the methods, these are what they do, and here are the key fields and relationships. And you'll actually specify the aggregations and compositions and the cardinalities like you would in a UML diagram, but we don't want to have you write diagrams in the exam because that's too hard to mark. You know, imagine, what is it, 650 sheets of paper that we had to plow through. So we're just like, no, don't worry about that. We'll just get you writing the prototypes. Cool. So that's that question. So there is domain modeling. Yeah. Yeah. Like, so you're talking about this one, written as comments. Yeah. So like you'll have a we might even go through an example and I can talk about it. So let's do a domain modeling question. And actually, this is a good one to do because it'll give you a feel for what we mean with this question. Because some people, like, we say it, and then some people just like either didn't listen or they just kind of don't do it properly. And we're like, well, that's kind of hard. We can't really award you marks for that, which is kind of sad because we know you put in a lot of effort. So we'll go through that later. Design by contract. There's usually a theory question about design by contract, which I'll talk about as well. Particularly design by contract with the Liskov substitution principle and how pre and post conditions interact is important to know there. Exceptions is all kind of your standard bread and butter, same with generics and collections. JUnit testing is like, there'll be a question with tests in it, and you might need to write some of your own tests, or you might want to write some of your own tests to do additional testing. Design principles is going to be a big, I mean, that's really, I think, like the most important lecture in the course because it's the bedrock around which all these conversations about good software design revolve. So there'll be questions that are like, this is good. Is this good design? Is this bad design? Compare these two approaches. Why is this design better? So you definitely know your solid principles, code smells, everything around this is important. Similarly with refactoring, there'll be a question that says, here's some code, explain why it's bad, go refactor it. Sounds familiar? Just like assignment 2. It's kind of like assignment 2, but a much smaller version that'll take you not how long assignment 2 took you. Functional paradigm. There's usually a question that is along the lines of, here's some code, refactor it to use streams, just like in lab 4. So make sure you're across your streams. You're familiar and happy with those. Everyone loves streams in this course. We learn streams, and then we're like, oh my God, you calm down on the streams, people. Like, they really like it. And then the patterns. Strategy, state, they're kind of the bread and butter. I would focus on like the big patterns: strategy, state, observer, composite. They're probably the biggest ones. And then also, like, again, if you're trying to go further and higher in the course, decorator is another big one. Templates also another big one. And then the rest of them are like good to do, but they're the ones that I would say is like, if you're just trying to get by in the course, get like a credit or a pass, then make sure you know those patterns. And then the other ones are they're accessible, but they're, I'd say, less core than those important patterns that we learned early on. Factory stuff's fair game. Generics, good to know that. Particularly around how generics work, again from the sort of theoretical point of view. Go back and have a look at the slides on those because they're quite good. The only patterns that I'll say are not going to be assessed, as far as I know, are these two, or these three, I should say. We normally mark them as bonus, but yeah, I don't think they're going to be in the exam. So take that as you will. Microservices, that's completely bonus, not in the exam. The stuff around event-driven design, around risk, that is fair game. The stuff around the unknown, that's fair game. There'll generally be like a theoretical question on these topics because they're sort of more like, waffly lectures rather than coding, but important to understand those as well. So that's the content of the course. That's what's in the exam. They're fair game. Yep. It's a good question. The question was, what is the exam environment like? I don't know is there much information here? There's not a whole lot here. So the exam environment, basically, think of a CSE machine. Like when you go to the labs to do your labs and then you log onto machines or you log onto VLab, except there's no internet access and there's no, like, you don't get any of your local files, but you'll get VS Code, you'll get Gradle, you'll get a very basic subset of VS Code extensions, specifically the ones that we tell you to install in Lab 1. So you'll get source action, you should get the spell checker and all those, like, it'd be kind of simple things that just like make your life a little bit better and mean you're not going to spend 3 hours just like debugging the fact that you spelled synchronized with S rather than Z. Like those sorts of problems. Because we're like, we want you to do as well as you can. But any like extra extensions that you've, gone and custom installed and spent 5 hours setting up, sorry, not happening. You're stuck with the basic exam environment. And Andrew Taylor was saying this in one of his lectures the other day. And he was like, sometimes you're going to have to SSH into some remote server and you don't get your lovely setup and configuration and you just got to deal with that and write code. So think of it as a good learning experience, for times like that. Does that answer your question? Yeah. Cool. Yes, sorry. Fair game that is a content that is accessible. Yep. Sorry, I should have clarified that. But all right, let's keep going. Any other questions? Nope. Okay, let's crack into some theory. Question 1. I don't know. Have you guys seen these questions? I know we've released some revision material, and then we released a sample exam. I don't know if these came as part of that. I have a feeling they might not have. That's okay. We'll step through this together. If you're watching this after, I would recommend go attempt this. This is a exam from a previous term. Again, slightly different format. You guys have multiple choice, less emphasis on the programming aspect. And this exam is designed for people having access to the internet, whereas you don't. So I would just bear that in mind, I guess. But most of the stuff's all, stuff we'd expect you to be able to do. Can anyone identify the logic error in the first function part A. Got an equals method, which you probably would have done in lab 2. The logic error. So it compiles and it runs fine, but it doesn't work correctly. No, that's fine. Because this can never be null. So then you won't get the case where you're accidentally returning true when you should return false because it's null. Process of elimination. So that line's fine. Are people happy with this line? Yep, seeing some nods. What about this line? Okay. Next question that might help with this is, what is the difference between instance of and get class? Yep. Instance of says yes to the subclasses, whereas get class is talking about the class itself. So you're right. If I have class A and then class B extends A, and then I make a new object which says B equals new B, right? And then I say B instance of A and B dot get class equals A dot class. So I ran out of space. What's the first one I'm going to return? Who thinks it's true? Who thinks it's false? Who's not sure? Cool. What about the second one? Who thinks it's true? Who thinks it's false? Who's not sure? Okay. The first one is true because B is an instance of A because all B's are A's. When we say B extends A, B is now an A. As part of its memory, it has a bit of subsection that's like, this is the A-related content, and then there's some B-related content as well. So all B's are A's, which means this is true, but the types are not the same, right? An object of type B has a different type to an object of type A. So get class actually gets the physical types. A dot class, B dot class. They're not the same thing. It compares those. That's false. Okay, that all makes sense. So why is there a bug here? You're almost there. Anyone want to help me out? It won't return false when it shouldn't. It will return true when it shouldn't. So if I have a class called like, news extends article, and then I have an object of type news. So I say, A dot equals new news. This will be true when it should be false, right? We wanted to compare the types, the actual physical types. But it's going to say, well, news is of type article, because that's how inheritance works. But in this case, we don't want that. So know when to use instance of, know when to use get class, right? They're different tools, they have different applications. Who's used instance of in their code, in the assignments? Cool, most of you. Okay, so that's the logic error. Write a failing assertion, basically just saying what we've done here. We make, say, okay, there's this news class extends article, a dot equals new news. And, it'll be something like assert false, false, blah, blah, blah. And then it'll return true when it shouldn't. That's our failing assertion. Make sense? Yep. Well, because when we, again, this is like you in answering the question have to be like, oh, well, there's a news class now as well. But in our news class, we're just going to inherit that equals method. Yes, but we're not talking about that anyway, because we're invoking it on the article one, right? This A is an article, which means this equals method's being called, not the other one. If we swap them, then you have to care about an object of type news implementation. But we're talking about the super method here. This is all the context you have, but like in this case, you're assuming that we don't want article and news to be the same thing, which generally when you do equals, that is the case, right? We don't want to use instance of what it should be is object dot get class equals get class. Cool. All right, number 2. Logic error. You think this is actually isn't a logic error, this is a runtime error. Can anyone tell me what runtime error is going to happen when we run this code? Removing stuff from the list while you're iterating through it. Correct, spot on. We've got a special name. Does anyone know it? Concurrent modification exception. That is what happens, and Java is very nice actually in doing this for us. It says, hey, you're looping through this list of numbers, and this numbers thing becomes an iterator under the hood. And we use that, say, okay, give me the next element, give me the next element, give me the next one. And then you've gone and actually modified the underlying data structure. And we talked about this in the iterators lecture, but in some languages like Python, it just kind of goes, oh, well, that's a you problem. Whereas Java goes, no, you can't do that. So it throws concurrent modification exception. So to catch it, I just need to say assert does not throw concurrent modification exception dot class without odd numbers new list. A bit of pseudocode is fine for these theory questions. Like this probably doesn't compile, but you get the idea. Cool. That's question 1. So this is very much about like design and correctness, I would say. Question 2. This one's about design principles. This kind of first question. Oh, let's see the snacks. Okay, I spent like $70. $70. Oh, I don't have like $21. Awesome. I just want to do an inspection. Oh, got Skittles. Oh, family pack of Tim Tams. Okay. Does anyone? Thank you very much, you two, for your service. Does anyone want to be of service and pass these around to people? Yep. Oh, you would. Oh, okay. Okay. I thought you were volunteering. I'm not going to eat these all myself, and I'm talking, so I can't pass them around. Does anyone? Okay. We had this big discussion last week in the teaching meeting about why people don't come to lectures. And they were like, well, if we bring lots of food, then they'll come to the lectures. And I don't know whether it's the promise of food that entices you here, but I mean, if you all leave, I'm like, okay, that won't work. But I'm hoping the food is nice. Anyway, what were we talking about? Oh, we were talking about question 2. Okay. This kind of question is like, you might get this in the exam because it's closed book and you should know what the dependency inversion principle is. So which one or multiple ones out of here would be? We encourage programming to an implementation, not an interface, an interface, not an implementation, abstractions, not concretions, concretions, not abstractions, black box, white box. Who reckons it's this one? There are multiple correct answers. Who reckons it's this one? Yep. Couple of people. Who reckons it's this one? Few more people. Cool. Who reckons it's this one? No one. Who thinks it's this one? Oh, love good black box. And this one. Okay, cool. So kind of like you kind of look at it, it's like, well, it's kind of saying the same thing. You know, there's just different versions of the, you know, of saying the same thing, but it's just flipped. So I would say this one's correct. This one's this one's correct, and this one's correct. And what they all have in common is this idea of abstraction, right? Where you say, I don't care how you did it. I don't care how it works under the hood. All I care about is that I have a function I can call, a class I can create, an endpoint I can hit that does it for me. And you say, create a new class, create an A, create a B, whatever, invoke a method on that, and that's it. So when you as a programmer if I go Python 3 and I say like help string, what I get is an interface, right? It gives me the interface to the string class. And it says, here's the methods you can invoke, and here's what they give you, right? The external behavior. It doesn't tell me how they're actually implemented under the hood. So we program, when we use this API or this class, we program to the interface that we're given, not the implementation. What word starting with C does that prevent or does that minimize? You got two options. You just got to pick one. Yep. Minimizes coupling. So when you program to a black box, your code is now no longer coupled to the implementation details of that function or that class or that API. And that means that if they change their stuff, your code still works because you program to the spec, not to the implementation. If you program to their code and their code changes, then your code doesn't work anymore, right? That's where the coupling comes in. Cool. Consider the angle class versus the maths help class. So let's skip this question. I'm gonna keep going, because we don't have a ton of time. All right, question 3. Now there's gonna be a question in the exam, kind of like this. You say, here's a problem. Here's about a paragraph of text describing a scenario. Pick a design pattern. In terms of approaching this question, if after a certain amount of time, you just get good at being like, okay, it's this, and you're like, that easy. If you're like, I don't know what pattern it is, and it's kind of ambiguous or whatever, look at it and then write down all the patterns. You're like, okay, the state, the strategy, and then just do process of elimination. Okay, well, it's not the decorated pattern, it's not the singleton pattern, it's not this pattern, and then you kind of get left with a few that you're like, okay, it could be this. All right, cool. I'll pick one, and we'll always say justify your decision. We'll always get you to explain why you picked a design pattern if it's like a short answer question. So in this one, thank you. Absolute legends. We're giving another round of applause for their excellent work. Feeding the class. An army runs on its stomach, and so did COMP2511 students doing design Java programming. Okay, so we're moving to Jira in 22T3, and we want to manage our projects. This is back when we had projects. And there are 3 different types of Jira boards: Scrum, Kanban, and bug tracking. All of the boards have the same flow of work, some features to support, including issue tracking, customization stuff, blah, blah, blah. Some elements may vary, though. The sprints are different, and there's a couple of other, how the boards actually work is kind of different. But they're sort of structurally similar. Once a project is created as Scrum, Kanban or bug tracking cannot change its type. Any thoughts for a design pattern for this question? What we usually do is we sort of give sentences that say that nudge it towards or away from a certain option. And so you can kind of look at that and go, well, I think this thing is leading me toward, this is a characteristic of a particular pattern that we've studied. For example, if you see the word state, then you think, well, maybe it's got something to do with the state pattern. It doesn't necessarily mean that it is. Like there's that question in the Duke where it's like the state changes and then blah, blah, blah happens. And everyone's like, oh, it's a state pattern. And it's actually the observer pattern. But it's good to like read into these and try and figure out, okay, this does this, and this is kind of similar to that pattern, and you can sort of figure it out. So any ideas here? Oh, yep. Template pattern. Anyone agree? Anyone disagree? Any other ideas? I think it's spot on. So it's a template pattern. Now the big question is why? What makes it a template pattern?
Because it says key characteristics that some things that are changing.
Yep. Yeah. Sounds pretty plausible. So we've got this idea of, okay, we've got a series of steps or like a structure in this case, and all boards have the same flow of work and allow for this and blah, blah, blah. So there's a series of elements which are the same, and then there's some parts which are different. And literally says this, some elements may vary for each type of board. So you think, okay, there's some bits that are the same, there's some bits that vary. So it's kind of like a template, right? Where, like you make a template on Microsoft Word and some of the bits are done for you, and then some bits of the template you have to fill out yourself. That's how the template pattern's structured. Now, once it's Scrum or Kanban or bug tracking, it cannot change its type. What pattern does that rule out? Yep. Yes, it does rule out state. There's another one which is a common red herring for this kind of question. Yeah. Rules out strategy. So a lot of people think, oh, well, a board, and people do this a lot in was it assignment 2? I don't know. I saw people do this a lot the other day. And this is a key thing here, and people often mess this up. They say, oh, well, you can have Scrum, you can have Kanban, you can have bug tracking. It's like a big switch statement. Therefore, it's a strategy pattern. Wrong. The strategy pattern, you need to be able to change its type. So an example is in what? I had it, it's gone now. An example is the restaurant booking, a restaurant. So it says, okay, I'm going to charge you at happy hour prices, right? Like slightly cheaper. Okay, now I'm going to charge you at normal prices. Okay, now I'm going to charge you at public holiday prices, where you have like a surcharge. So that chops and changes strategies as you go. That's a strategy pattern, because you can say, okay, now I'm going to change to this strategy. I'm going to do this for a bit. Okay, we're going to go back here. And there's always this dynamic element to it. Whereas here, it's like, nope, your Scrum, that's it. Your Kanban, that's it. You don't change. Some people also confuse like a strategy pattern or sometimes a template pattern for just like plain old inheritance. And they're not necessarily the same. The template pattern, you need this like structure or a series of steps. Some steps are filled out by the abstract class, and some steps you have to fill in yourself. Okay. Any questions so far? That's question 3. So the other thing for these exam questions is, please don't write us War and Peace in terms of like, you don't need to write a whole lot of stuff. I've marked exam questions that were like a page long, and they didn't get the marks because they didn't hit on the points that the question was asking for. I've marked responses that are like a sentence long, and they get 5 out of 5 or 4 out of 4 or whatever it is, just because they answer the question. So here, if it's like you hit the pattern correctly, or at least you hit a plausible answer and you made a good justification, you hit all of the key characteristics. So here it's like the template pattern. What steps are common in the superclass in the template? What steps need to be filled out by Scrum, Kanban, bug tracking. And it's not a strategy pattern because it's static, right? It's not a dynamic type. Those are like the key points that we'd want to hear in the answer. So if you hit all the key points, then you get all the marks. Plain and simple. Okay. 3:46. We'll do some coding in the second hour. I want to do this question. And I want to do what else? I think I'll do question question 5 as well. We'll skip this Sydney Swans one. Okay, question 5. There'll probably be a question like this as well. It's pretty common. We'll give you some code and we'll say, what are the code smells? Please write them down. And maybe like what you would need to do to fix the code smells. So this one, hopefully you're kind of familiar with. We also, in this particular question, we say, identify the smells, and we also say, identify the underlying design problem. Remember in assignment 2, we kind of talked about, in part 1, there's, okay, find the smell, find the design problem, fix the design problem by refactoring. So sometimes, in the case of part B here, we don't really have enough information to tell if there's an underlying design problem, but there is a code smell or a design smell. What do you think it is? Yeah, right. It's got like 100 parameters. Again, that's just the thing we can't look at, and it's hopefully instinctively like, oh, that's a bit weird. Still a lot of parameters. Sometimes that's like indicative of maybe the method's trying to do too much. Maybe it's trying to, but it's not actually doing anything interesting. We haven't given you the code, so you can't really tell. And that's what you'd say. This one, hopefully you are familiar with because it's pretty similar to assignment 1. What are some smells and what might be some underlying design problems? Yeah, there's a bit of dry going on. Don't repeat yourself. What else? That's a smell. Yep. Okay. Yeah, I don't know if I wouldn't say it's violating a single responsibility. I would say it's violating law of Demeter in the sense not even law of Demeter. It's just trying to do too much. I would probably just call this feature envy actually, right? Saying S dot do this, S dot do this, S dot do this. You're like, you might as well give it to the S, right? That's feature envy. We might as well just say S dot update position, and this is just like a method inside update position. What though is what's the design problem, right? There's something at the root of this, and you can kind of just tell it by looking at the code. Yep. Yeah. It even like it's you can infer that standard satellites and quantum satellites are both of the same type. So you say, well, let's just have a single list of satellites, and maybe there's inheritance, maybe there's not. We don't really have enough information to tell, but and probably many of you did this in your assignment is you have subclasses, and then each of those subclasses have specific behaviors. So these two can be delegated to a standard satellite class and a quantum satellite class respectively, and they do their own thing. And as simulate, you don't care. You just call the method. You're just like, give me a satellite, I'll update its position. Cool. All right. Liskov substitution principle. This is a just a fun one from a theoretical point of view, because it kind of like, I think once you get it, it makes sense, but often it takes a bit of time to understand. So during assignment 2, someone said, oh, can we modify the position class that's given to us? You know, like in the Dungeon Mania code base. And we said, you can, but you can't break the preconditions and the postconditions of the class because we will rely on those for auto marking. So what do we mean by breaking the preconditions and the postconditions? What do we mean by breaking the preconditions? Yeah. The conditions that occur kind of before and after the function runs. So I'll give you the position class just to kind of give some context. Oh, sorry, this is the wrong one. Figures. No, here we go. Position.java. So let's say this has a precondition and a postcondition. How do I break the preconditions? If I make a subclass or I change this class in some way, we have this idea of here's an original class and we're going to make a new class. And in the theory, we say, oh, we'll make a subclass, but in this question, we're just going to change it. How do you break the preconditions? The way to break them is by strengthening them. So by the LSP, you can only weaken preconditions, not strengthen them. It's like saying, okay, the preconditions for COMP2511 are COMP2521 and COMP1531. And then I'm going to make a new class or like a new version of the course called COMP2511 V2. And that has preconditions. Well, actually, you only need to have taken COMP2521. Now, everyone who enrolled in the course now can still enroll in this new course, right? We haven't made it harder for you to enroll in the course. We've made it easier. So in this case, we have weakened the preconditions for enrollment in the course. That's fine. That doesn't break the Liskov substitution principle. But if I then said, haha, you did all that work to get into this course, you actually have to have done comp, I don't know, 9999. Doesn't even exist. What have we done here? Have we weakened or strengthened the preconditions? We've strengthened them, right? We've constricted the domain of valid input into the function. And so now all of you were able to work in the base class, but not in the subclass. What does the Liskov substitution principle say? Does anyone know it by heart? You might want to learn that for the exam. LSP, all subtypes must be substitutable for their base types. All subtypes must be substitutable for their base types. That, in effect, is saying, in this course analogy, if you guys were able to enroll in the course before, you should still be able to enroll in the course now. We can't sort of pull a fast one on you and go, psych, too bad, right? So that's the preconditions. The postconditions is the same thing in reverse, except instead of being able to weaken them, I can strengthen them. So I can say, let's take a different example. Let's say you have a flight, right? And you buy a ticket to the flight. And so version 1 is you obviously, it gets you to the destination, postconditions, gets you to destination, and then you get a free meal. And then version 2, the postconditions, well, actually, we got you to the destination, but we're not going to give you a free meal. And you're like, I paid for that free meal. I guess it's not really 3 meal in that case. This is maybe a bad example. Let's say it gives you the free meal, but it doesn't get you to the destination. Some plane flight, that is. Okay. How have we broken the post conditions here? What have we done to them? We've weakened them. You're like, I paid for this plane ticket, and now you're not going to even get me to the destination. Whereas if you strengthen the post conditions, so instead I say, okay, it gets you to the destination, you get your free meal, and you also get an umbrella, right? Here's your umbrella. Then you're like, great, that's awesome. You know, I got everything that I got before, and I get more. So that's like a non-coding way of explaining this idea of contractual design. Is you have a contract by using the class. You have a contract, you know, like a contract of sorts, you know, in the course analogy, in the flight analogy, and essentially you in creating new classes, which are subclasses of, you know, B extends A, V1, V2 extends V1. You can't break that contract because all subtypes have to be substitutable for their base types. In code, what does that look like? It looks like this. So I've got a variable called flight v1 equals new flight v2. And in our class, you know, in our inheritance structure, we've got v1 and then v2, which extends v1. So I should be able to do this and then say, you know, oh, sorry, I've got a method called fly. And they have their associated preconditions and postconditions. I'll call this F. So I should say F dot fly. And because its static type is of type flight v1, how do we expect it to behave? Its static type of F is flight v1. How do we expect it to behave? Right. We expect it to behave like a v1 because we said it was a v1. But if we go and change the behavior by breaking the preconditions or the postconditions, then it no longer is a flight v1. This becomes invalid inheritance. And it breaks LFP. Does that make sense to everyone? Hopefully there's this like intuitive understanding of this idea of a contract, and you don't want to break the contract. If you break the contract, you break LSP, and introduce this logic error into your program. Any questions on the theory? Yes. Yeah, a quick skim. Sure, I can do that. Let me just stop sharing. I'm just going to freeze the image and bring up some old notes. Oh, freeze. There we go. Freeze. Here we go. Mm-hmm. Sorry, I thought I had a solution from last year sometime. I'll just see if I can get on my local. Uh, Here we go. Um, questions. Okay, questions. All right, I'll run through on the design patterns and I'll start sharing screen again. Zoom. Okay, there we go. These are some notes on like what I would think is like the key characteristics of each pattern. And like when we say to you, come on, there we go. When we say to you, tell us, map the scenario or map the problem to the key characteristics of the pattern. These are kind of the things we're looking for. So as I said, strategy, dynamically change strategies at runtime. You can add or remove strategies at will. So if you say, okay, here's a new way of charging people in the restaurant, which we're going to use tomorrow, you just make a new strategy class and then go about your business. There's limited logic around changing strategies. And what I mean by that is that you should be able to chop and change between strategies without there being, you can only go to, like when you tap on with an Opal card, for example, you can only go to tap on when you are currently tapped off, right? If you go to tap on and then tap on again, then it's the same. So those sorts of like things where there's logic around transitions is what pattern? State pattern. Yeah, exactly. So as soon as you start introducing rules about, okay, you can only do this when it's in this state, and when you do this action, it'll transition to this other state, that's when we get to a state pattern. The state pattern, you obviously have states with actions which cause transitions, and then there's logic around those actions. Often if it's a state pattern, we'll say, fill out a state table. We won't say draw a state diagram because there's no drawing diagrams in the exam. Composite pattern, what are your compound nodes? What are your leaf nodes? What is the hierarchy, right? Like in the file system example, your compound nodes are directories and your leaf nodes are files. And there should be some sort of abstraction. Again, it's like you could be talking about a compound or a leaf node. It doesn't matter. They all comply to the same interface. Observer pattern, you've got the thing being observed, which we call the subject, the consumer, the subscriber, sorry, this is wrong. This is the producer. The thing being observed, the subject or the producer, and then the thing doing the observing, which is the observer, the subscriber, the listener. Question? No, I will not say, I will never blanket rule. I mean, there won't be another Boolean logic question because you've already had like 10 of those in the course already. But like the thing with that is like, if you apply this thing here, it's like, okay, well, our compound nodes are you know, an and node, an or node, and not node. Leaf nodes are the actual like Boolean true and false themselves. There's a tree hierarchy because you could represent this Boolean logic as a tree. So like, I know that wasn't your question, but like, you know, you can apply the same characteristics. And the good thing about having done a bunch of patterns in the assignments and the labs already is that you get this feel for like, okay, it's this kind of thing, which is kind of similar to the lab. So maybe it is a composite pattern, or maybe it is a strategy pattern. Cool. Awesome. Method of notification, change in state that causes the updating of notification. Again, this is like that second question in part 1 of assignment 2, where we say, you know, talk about the key characteristics of the observer pattern in, you know, one part of the code base and how that's implemented. So hopefully none of this stuff is like extremely new to you because you've been doing it all term in the labs and the assignments. Factory, a factory pattern, just an object that creates other objects. And there's usually some sort of logic around that creation. Decorator pattern, we dynamically add functionality. That's another key thing with the decorator pattern is that you can suddenly be like, okay, and now I'm going to add this other thing as well, and this other thing, and this other thing. And that all happens at runtime. Layering or wrapping, decorate to an interface, not an implementation. Template, we talked about. Visitor, yeah, separate the algorithm and the implementation. And iterator, we want to abstract traversal from a container or an algorithm. Yep. Oh, sorry, I forgot to talk about hook methods. Yeah, I completely. Usually, it's I don't know if we wouldn't like take marks off, but in a template pattern, if there's a question like the Kanban one we just had before. Sorry, I forgot to mention it, but you should always talk about the hook method. The hook method is just the bit of the template that you need to fill out. That's just what we call it for. So when you have a template, say, okay, this part filled out for you, like in the Scrum one, we had. I don't remember. Let me go back to it. That's not what I wanted. Here we go, Kanban. All boards have the same flow of work, the same blah, blah, blah. So they're the pre-filled parts of the template. And then the hooks are the types of sprints in this case, or the structure of the projects, where the Scrum has the 2-week sprints, the Kanban has the epics, the bug tracking just has the backlog. So that's your hook in this case. I would use the term hook methods because that shows your marker, unlike me. It shows the marker that you understand the pattern and understand the terminology. If you didn't say it, and like the thing with a lot of these short answer questions is that if we can understand that you understand the concept, then you'll get the marks. But if you can't demonstrate that you know what you're talking about, then we can't like be mind readers in that case. Get some questions where like most of the time I know what they're talking about. I'm like, I understand what you're trying to say, and maybe you just didn't say it that well. That's fine. Exams are tough, so you know we're not going to be like you have to write this perfectly. But if there's some questions that I've marked in the past where I'm just like I have no clue what you were trying to talk about, you might have done this in the last 30 seconds just as like a Hail Mary. Again, that's how exams work, but as long as you're clear about what you mean, then that's chill. Okay. Where were we? Oh, we were talking about the patterns and any other questions. Sorry, not Haskell. Any other questions people have about the patterns? Yeah. We can. I don't think there's going to be a visit pattern question in the exam though. So if people don't want to, if you're like, well, I only want to talk about stuff in the exam, then I'd like the only reason I say that, like, it's a good pattern. And I want it to be put back in the labs next term, but it's very hard to come up with a situation where you'd really want to use a visitor pattern because it's essentially like adding on to an existing thing that you can't necessarily change. And most of the time, like in assignment 2, you can just go in and fix the code. You don't have to be like, oh, let's add on this whole other visitor, infrastructure that works around the existing code. That's when visitor's really good, is you just like, okay, I just want to add something on rather than having to go in and change everything. Yeah. Yeah, there's gonna be no visitor in the exam, so I wouldn't worry about it. Yes. Yep. That's a good one to know. Yes. Oh, that's a good question. So it's the how notification works. Um, where is it? Oh yeah, method notification. That's actually in sorry. Uh, my desktop is all over the place today. Sample exam. That's this question. Question 4, where we say what implementation. So a push notification is like what you all have on your phones, right? Where the producer of events, the thing that is giving you the update, is it's giving you the update. They're pushed out to you. I send you an email being like, the assignment 2 marks are out. I'll do that on Saturday or Sunday. You get a notification, right? It's pushed from me out to 500 students. Pull notification is your polling. You're saying, okay, it's like students that like every couple of days they're like, oh, it's my mark out, and they check the give thing. Sorry, could you close that, please? That's shining in my eye. Thank you. Oh, you're all good. You're good. That's right. I just got this blinding flash of light. And I was like, oh. Yeah. So like students that check their marks every couple of days, you're polling the SMS or the Give website for your marks. That's like a pull notification. Is you as the observer are doing the update. If that makes sense. Does that answer your question?
So like in the code, some push I know like after the event state code
Yeah, it could call the thing being observed directly, or it might be through some sort of proxy, right? Or some sort of intermediate object saying, give me the update. Whereas push is saying, here's the update.
Yeah, but like on the so tool is like chicken on it.
Yeah.
So that we like better observing right in such
Yeah, I wouldn't get too hung up on the implementation details, mainly because push is the primary method by which observer patterns implemented, where you're like, okay, send out the notification, have a loop where you loop to all the subscribers and then update each of them. But a pull could be like once every 24 hours, a cron job or some sort of automated task runs, and that checks the updates from the server. Right, that's a pull observer pattern.
right. Yeah.
Yeah, cool. It's hard. I would say this one's hard to go in code, so we managed to show you push. Great. It's 4:15. I'm gonna do. What am I gonna do? We're gonna do modeling after the break, and then I'm gonna talk about. What am I gonna talk about? I don't know. We'll see how we go with modeling, and then I'll show you. I'll try and maybe run through one part of the coding question. But if you want to watch some more coding, then there's lots of previous recordings where I've gone through this particular question. So let's have a 5-minute break. We'll come back at 4:20. More questions. Keep them coming. They've been really good so far. Yes. All right, let's crack on. I apologize for taking an extended break. Come on. Come on. Freeze images off. There we go. Yeah. I'm gonna put them on Confluence tonight. I'm sorry I didn't put them up earlier. I have my thesis due tomorrow, so I'm kind of swamped at the moment. Share screen. Okay. There we go. Yeah, so I'm going to put these questions that we went through today. This is from, as I said before, a past exam that was all online, so slightly different structurally, but like I'm just going for questions and for content and for concepts here. Okay, so what we're going to do now is the modeling question, and I'm going to do it like you would do it in the exam. Okay, here's the question. So, bit of pretext, online newspapers, blah, blah, blah. So we have these articles called live article, which you can have real-time updates and new posts are made on the live article. So at 7:40 a.m., continued military drills bring greater risk of miscalculation, says the defense minister, or whatever. So this is an article, you make new posts to the article. Immediately, hopefully in your head, you're like, okay, some sort of relationship between this idea of an article and this idea of a post, and maybe an article has an author as well. So start to think about the entities, what's happening in the system, what's the domain model, what's the problem space looking like. Then we actually give you some very specific functional requirements which you can work to. So we just have this idea of, okay, well, we can make a new live article, we can store it, we can make a new post on a particular article that has a content, post title, and time was created. Existing posts can be updated, existing posts can be deleted. So this is all basic CRUD stuff, right? Like you've done this to death. And a comment can be made on a post. Model the domain to form the basis of potential software solutions. This is just prototyping, this is just planning, just designing. You should include interfaces, class signatures, method signatures, key fields, and relationships. Now, if interfaces or abstract classes or like a particular structure isn't applicable, don't worry about it. You're just saying, here's the requirements, here's my design. You don't need to use a pattern. You don't need to use a particular thing. But we just want to say, here's my design, right? And if you do that, then you'll be fine with this question. So let's do it. I'm gonna do what we did back in lab 3, and I'm gonna model out the requirements, and I'm gonna do it like this. I'm gonna paste, not that. Control V. Cool. Okay. New live article can be created. So let's have our list of entities. Live article. Okay, a post, that's another entity. What's another entity? Okay, that's existing post can be deleted, comment can be made. Do we need a comment as an entity? Maybe, maybe not. Okay, that's probably all we need so far. There are 2 main entities. And then on the live article, we'll have functionality. We can make a new post. We can add a comment on a post. And we can delete a post on an article. Can we update a post? No, we can't. Oh no, we can't update a post, sorry. Post on an article. Cool. Okay, and then the relationships. What's an immediate relationship that we can identify here? What does an article contain? Yep, series of posts. Now, okay, next question. Is it aggregation or composition? Someone said aggregation. Who thinks it's aggregation? Who thinks it's composition? Who is not sure? Okay. Why aggregation? You can have an article with no post. Yeah. So can you have a post without an article? I'll just go back to the picture again. So if you get rid of the article, does it make sense for the post to exist? Not really. So I would call that a composition. And then the cardinality would be, well, one article can contain zero or more posts. And like, again, there's no particular notation we're going for, as long as you make it clear that this is okay, 1 to 0 to more, just like on a UML diagram, you're chill. That's all we need. Okay, that seems pretty good. This is the kind of thing you might want to do on scribble paper. I don't think you can write during reading time, but you could think about this during reading time. I don't even know if we give reading time. That's a good question. I'll clarify that for the exam. Post composition. There are entities, there are functionality. Are we missing anything? I think that's, oh, actually, there's one more relationship, which is kind of implicit. We talked about this idea of, okay, you can create a new live article, but what are you creating the live article in? What contains all of the articles? Website, yeah. I'll give you a hint. It's already here. Yeah, the system, right? Like, could be the website, whatever. It's just like the system contains a series of articles. So let's do it. Again, don't have to implement any of these methods. We're just going to have our fields and the relationships and the prototypes. So we'll say, make a new class called article or live article.java. And that's going to have private list posts. And we'll make our post.java class. What's that going to have? Private string content. Oops, that's not what I wanted. Private local date time. Private, or like last modified. Private list string comments. Got to import that. And that looks good. That looks good. If I go back here, am I missing things? Okay, I need to add my relationships, and I probably need to add some of this functionality. Okay, let's go to live article. So we'll say composition, 1 to many relationship. That's all you need to say. And then we'll have a public void add post. Yeah. Yeah. Because you're saying, because it's a list here, it's like, well, one of this has many of this. I don't think there's really any situations in this question, at least, where you'd have that like bi-directional coupling. But if you did, you could just like say it in the comment. I don't know why it's yelling at me. Oh, I haven't. No, that's not it. Equals null. That's weird. Add post string content. And I don't even need to say post.add post, like if you wanted to, but I'm just going to return void, return nothing. Public, what else can I do? Existing post can have its content updated. Okay, we'll have public void update content. And I think that's it. Cool. Okay, now let's go to live article. Oh no, hang on. Sorry. I've messed this up. This should be going in the post class. We probably want a constructor as well. Public post string content created. And again, you can just leave this blank. Okay, update content, and then in live article, we can add a post. Say public void delete post. Something like that. Maybe you're like, okay, we need to return the ID. I'm not too fussed about this sort of thing. Like, the semantics of how exactly someone uses your system. If you've done assignment 3 and had to do like, think about, oh, how is the user going to use these classes and which classes are hidden and which classes are revealed? Think of it as just like assignment 1, where all they can access is the controller. And you can see that we've actually given you, it'll give back the string, which is probably the ID, and then you can use that to go and update or delete a post. So long as it's consistent, that's all we really care about. So in this case, we probably need to have a thing that's like public void update post. And then you get the post ID and string new content. That looks good. That looks good. Add comment, string post ID. We probably also want to have something that's like public void add comment to post. And this will talk to the post class, you know, if you were going to actually implement it. And the only other thing we need to do, say private list article, live articles. Oh, sorry, it's called live article. Live article. And this one will be a composition. And one system will have 0 to many articles. Get rid of that. I think that's it. I'll just go back to the requirements, see if I missed anything. No, I think that's okay. Any questions? Yeah. Yeah, sure. I can give that to you. Yeah. Someone's going to look at it and they're going to go, does this make sense? So like basically we'll have our solution, and then like we'll look at your design. If there's weird design choices around, like you did, like let's say you didn't include the live article class. Like, okay, that makes sense. We'll take off some marks. So it's manually marked, it's subjectively marked, and it really is a case of like, based on the requirements, how good is your design? And when I say how good is your design, it's not even like, did you use patterns? Did you code smells? Because there's no code. It's all an interface. And if your interfaces make sense, and if, someone could take your solution and then go and actually build the thing, that's pretty good. Does that answer your question? Cool. Other questions? Awesome. Okay. We've got 20 minutes left. And I think I have enough steam left to do some more coding. So let's talk about refactoring. Let's talk about this question 14. So there used to be a lab called SSO where you did stuff around authentication. That was fun. This question is not about that, but it's about permissions and access. So in GitLab, you're probably all familiar with the idea of a group, right? Like you have your student group, which has your Z ID in it, and then it has all your repos. And then for assignment 2, you had a group, which was your team. And so you have permissions on the group, which means that you automatically have permissions on the repo. And that's kind of what this says here. So in GitLab, there are 2 types of nodes in a structural tree of permissions and access. There's groups and there's projects. So me, it's like I have access to the group that encompasses everything, which means that I can see everything in the whole, everything, that's a part of the subtree. So here it's like you can see 22T2, you can see inside teams, student staff, and then everything within that. And that's kind of what that says here. A user can have permissions, blah, blah, blah. Now, the first question is, what design pattern is present here? There's a word that gives it away. Oops, sorry. Composite pattern. Yep. Okay. What are the key characteristics of the composite pattern? Tree structure. Yep. What kind of nodes? Yep. Leaf nodes. What kind of nodes? What are the compound nodes here? Group. Yep, so a compound node is a group. A group can contain other groups, or it can contain repos. What's the leaf node? The project, right? Or the repos. Yeah, we call it project here. Cool. So that's the first question done. That gives you a few marks. Now, we did that. Identify what you think is the main design problem present in the existing code, including what smells are indicating the problem. So let's go and actually have a look at the code. So we have an exception class. That's not very interesting. This is the later part of the question where you do a factory pattern. Okay, this is a GitLab group, right? So this is our compound node. Okay, we implement this interface. All right, cool. We have to implement a bunch of stuff with the interface. That's fine. We have members and subgroups. All right, we have this thing here. Blah, blah, blah. Create subgroup, get user permissions, authorize to JSON. Okay, that's our interface. Okay, GitLab project. These are our leaf nodes. What's something that you immediately notice scrolling through this code? Yeah, bit of dry going on. Okay, that's the thing. And then we have this, which is a singleton pattern. That's an enum. That's a user. Okay, cool. So like you're thinking at this point, the main things in this question are these two, GitLab project and GitLab group, these classes. So the question asks, okay, what is the main design problem present in the existing code? What are the smells indicating the problem? Okay, well, the smell is the repeated code. What's the design problem? We've got GitLab group and GitLab project, and both of these implement this interface, but they have a bunch of repeated code. Change to inheritance. I think it's a good solution. Like I would say the problem is that the inheritance structure doesn't allow the common code to be abstracted, right? You can't, like, because it's an interface, you can't pull out all the common code into the interface because that's, I mean, you could use default methods, I guess, but that'd be kind of ugly. And as you said, the solution is to use what? An abstract class. So you're like, okay, it's just kind of like lab 2, right? Where you say, the dry in the 3 hotel classes, you change the interface to an abstract class, pull everything up. So a lot of the stuff in the exam, we're not going to try and give you anything new because design is already hard enough, and we'd rather have you go, okay, this is like that lab, and it's not like the exact same, but it's kind of similar, and you can go, here's that. I mean, that's what design patterns literally are. It's like, I've done this sort of thing before. It's a bit similar. I could apply these same characteristics to this problem. This isn't like a design pattern as such, but you like abstract classes are a thing, so let's use that. And let's do it. Let's say public abstract class GitLab permissions node. Now, one little catch before I go and change anything is that there's a bunch of tests, and I might embarrass myself because my test runner's not working. Oh no, it is working. Okay. Blah blah blah. Okay, this doesn't work because I haven't done part D yet. But if I run all the regression tests, you see that they pass. Okay, we need to make sure they stay passing. So same as assignment 2, we expect all the regression tests to remain passing. Where was I? No, sorry, we're in GitLab permissions node. So we changed this to an abstract class. Now these are all going to spit the dummy. And what we need to do is figure out, well, what's the common code that we're going to pull up into the abstract class? Okay. Let's GitLab project, GitLab group. Okay, well, these name and members are both the same. So let's take them out and put them here. Cool. All right. We'll get name. That's just this. So that's pretty straightforward. Get rid of that. Set name, that's the same. Oops. Get user permissions. Okay, GitLab project, that's there. GitLab group. Oh, that's also there. Okay, let's copy these two because these look quite similar and paste them here. It's going to spit the dummy because they already exist. I'm going to change these to not be overrides anymore because we're now in the superclass. Authorize is missing. Okay, I probably need to copy that as well. Let's just take that, copy, and paste. Okay, looking a bit better. A few less red lines. Run pipeline to JSON, create project, update user permissions. Did I copy that over already? Yeah, I did. Okay, so we can get rid of that. We can get rid of this stuff. Anything left in the group class? Okay, so this create subgroup and create project must override or implement a super type method. These are not the same in GitLab project and GitLab group. Oh, sorry, I'll just get rid of that as well. Get rid of all this stuff here. Oh no, hang on. Sorry, I've done that in the wrong place. Whoops. No, we want to keep that. In GitLab group. Basically, I'm just trying to take out all the common code. GitLab group. Okay. All right. Looks like we've done most of the refactoring. We probably want to move this as well. Sorry. Into the permissions node. Okay, this is looking a bit better. This is going to not enjoy this because I'm overriding. I need to change this to extends, then it might like me a bit more. Cool, that's better. Now we get a constructor. Okay, it's looking slowly a bit better. When you change this to get name. What else is wrong? That looks fine for now. Abstract class, permissions node, extends. GitLab project. Oh, sorry, oh no. Cool. All right, GitLab project is not is compiling now. GitLab groups compiling. The only thing is that it doesn't like this because we need to either implement it or mark it as abstract. So I'm just going to mark all these three methods as abstract. So, okay, create subgroup and create project have different behaviors for GitLab group and GitLab project. And you're like, that makes sense, right? Because on a project, you can't actually create any subnodes, right? That's the whole point of the leaf node is you don't make anything beneath that. There's a code smell here. I'd like you to figure out what it is while I finish fixing the code. The method authorizes undefined. Why? Oh, I need to take this out of here. I'm kind of being a bit messy just because I know we're short on time and I don't want to keep anyone too long, but I'm going to say super. Oh, maybe what I should do is make this protected. And I can do this is fine because it's a method. I can't do this with a field. We don't like protected fields. But with methods, it's okay because they're different. Cool. All right. So you kind of played a bit of, get rid of the red line, solve the puzzle. And now if we go back to our tests and run them again, hopefully they don't fail. But they do, which is bad. Test to JSON, GitLab regression test. Expected name, but none found. Huh. Interesting. This not name is name. This looks fine. Why is my test failing? Test 2 JSON. Okay, so does everything else work? Okay. Assertion error, subgroup 0 to subgroup 0, expected name, but none found. Expected name. Fascinating. Create project, string name. Oh, I know what's wrong. It's been a bit sneaky. We've actually forgotten to refactor some methods out. Okay, get name. Cool. I found my bug. And hopefully the regression tests now work. Oh, look at that. Happy days. Good job. That's refactoring. I don't have a whole lot of time to go through the rest of the question, but you know, like you might get given a question that's like build this thing from scratch. There'll be a question that's around refactoring. Sometimes there might be like again like a mini version of assignment 2 where it's like, okay, part 1 is look at analyze the code. What are the code smells? Part 2, refactor it. Part 3, now add a new feature. And that's kind of what this question is built around, where this part, this filtering authorization stuff is a bit harder. And you know, there'll be those questions that are kind of a bit tricky. They're for the people who are trying to do very well. And often they'll be worth like less and less marks. But often there'll be a question that's just like, go implement this pattern. And in this case, I think it's like you got to choose either factory or singleton. And that was the last part of the question. You just go and do that and implement the pattern. 4:54. Okay, 5 minutes. Any final questions? Yep. How long will it take? It's a 3-hour exam. Yep. As in, I say you have 3 hours to complete the exam. Might take longer. Most people spend most of the time working. Like feedback we've gotten in the past from students, particularly with these exams, is the exam has been quite long. We know we always try and make it finishable. Like it always is finishable, but if you're not as strong or as confident, that's fine. Just like I wouldn't, like if you haven't got super awesome marks in assignments 1 and 2, I wouldn't go in expecting to like get blitz the whole thing. If you've done well in the assignments, exam should be pretty fine. Other questions? Cool. Yeah. Question 10. Yeah, sure. This one? Oh, yeah, this one I think literally didn't make grammatical sense. Like this method could take in a box or box. I didn't write this question, so I am. Yeah, we really need to fix that. Consider the following method. Okay, so there's some statements about generics. A generic class used without type arguments is known as a raw type. That's true. You cannot instantiate an array of a generic type using a new operator. That's also true. I honestly I wouldn't worry too much about this. Like that second statement is like I wouldn't put that in an exam because that's a test of how well you know Java, and the course isn't a measure of like how well you know Java. It's like everything you've done in Java, you should know like for all the programming and stuff, but these sorts of like very specific questions about how Java works, me as the person like helping write the exam is not super interested in. So we're more interested in design. Yeah. That's a great question. So that's sorry, when I like I don't want to box myself in here, but that's a design question because that's a design question that impacts correctness because you need to understand inheritance and okay, here's this tool that allows me to do this design thing, which is instance of, and this one on the whiteboard. And like because of the fact that we covered it in the tute and lab, we'd expect you to know it. Whereas this, I don't think we really covered anywhere that you can't create generics of arrays. So that's why I'm like, I wouldn't like lose sleep over not knowing everything about Java. Yeah. Who wrote it? Which one? Sure. Well, no one's written the exam because it hasn't been written yet. But I write the exam with Ashesh and the tutors sit it and run it. Like we get a couple of tutors to sit it as a practice test. So yeah. But I mean, it doesn't really matter who's writing it. But my point is that like what we as the course are interested in assessing, based on what you've been doing for the last 10 weeks is not like, are you the world expert at Java? It's like, can you write good software? Cool. Yeah. This one? Yeah, I think someone asked that earlier. So I'll put the solutions in a repo called like exam revision live stream solutions. I'll put this paper, all the relevant questions from this paper. There's one question which is like we don't do in the course anymore, so I'm not going to include that. But yeah, this will go on Confluence. Recording will be made available as well. If you got any questions about anything I said, you're welcome to post on the forum as well. Sometimes I like say stuff and people are like, what about this? And I'm like, oh no, that's not what I meant. So that's all good. Good luck. I'll see you all next Thursday. The exam's Thursday. Yeah, next Thursday. And you'll be fine. Keep studying, keep asking questions, and thank you for coming. And I hope you enjoyed the snacks. I need to pay you back, by the way. And thank you to people watching the recording as well. Goodbye.